So we're still on the front of that second page. We have our graphs here. We graph the inverses with, without having the actual line segments there. And then what do inverses do? Well, if you plug a number into a function, substitute is really the right word to use there. If you substitute a number into a function, it generally will output a new or different number. And it says generally there because what it's saying is, if I substitute 5 into a function, yeah, I could get 5 back out, but most of the time it's some other number, right? So it says, for example, we plug x equals 2 into this function. What do we get? 5. Good. I know it was a really hard question. 5. All right. Now, if we plug that answer into the inverse function, so if we take 5 and substitute it into the inverse, the answer should be 2. So I substitute in an x, I get a y. If you substitute the y into the inverse, you get the x back, right? Because we switched x and y. That's what's happening there. So this is because an inverse function will essentially undo a function. So if we plug x into a function and then plug the output, which is your y, into the inverse, we should end up with x again. So you're doing it, you're undoing it. You're multiplying by 2, and then you're dividing by 2, or whatever it is. Okay? Easy enough? All right, good deal. So inverse functions, how we show that they are or figure out whether or not they are actual inverses of each other. So if two functions f and g are inverses, and g can be an inverse. It doesn't have to have that little -1. Just depends on how we name it. I mean, they're saying they're inverses. So this is true if we do compositions and f of g of x equals x and g of f of x equals x. Okay, they both have to equal x. Now, if you remember when we did compositions before Christmas, we showed a few times that if I do f of g of x and then g of f of x, the answers weren't the same, because they aren't always. In this case, they are, and they're both x. That's because they are inverses, not because it happens every time you ever do an inverse. Ever do a composition. So to show that two functions are inverses, we must show that the f of f inverse of x and f inverse of f of x are both equal to x. And they can ask the question a couple of different ways. The first way here, it says let f and g be these functions, and they give them to me. This says determine if they are inverses. They're not telling me they are. They're saying, here's two functions, determine if they are. Tell me whether or not they are. So we're going to do that by the compositions. We're going to start by finding f of g of x. So f of g of x equals f of, and then g of x is 1/2 x plus 3/2. So that means I'm going to take this and substitute it into f everywhere I see an x. So this is going to be 2 times 1/2 x plus 3/2, and then I still have that minus 3. Everybody good so far? Then I distribute. 2 times 1/2 x is x, plus 2 times 3/2 is 3, minus 3, and then that just gives me x. So that tells me I'm on the right track, but it doesn't guarantee anything because I have to look at both of them. Because maybe this one works, but maybe going the other way it doesn't. So now we're going to find g of f of x. So I want g of 2x minus 3. So now I take this and put it in here everywhere I see an x. So this will be 1/2 times 2x minus 3 plus 3/2. Then I distribute. 1/2 times 2x is just x. 1/2 times a -3 is a -3/2 plus 3/2, which gives me x. So since I did the compositions and they both get x, it says determine if. So then I can say f and g are inverses. And my why statement, like my because, is my work. So I don't have to go any farther with my explanation or anything. What questions you got? All right. Now, then it says, sometimes we must use a restricted domain to ensure two functions are inverses. So if you look at example 7, it says, show that h and k are inverses where x is greater than or equal to 10. So let me show you why we have to do that. I'm going to go back and let's look at this picture we graphed yesterday. So what they gave me is a parabola. And then our inverse is what is in blue. My domain for my original one is all real numbers, right? My domain for my inverse, is it all real numbers? No. I start here at 0 and I go from 0 to infinity. So I can't use all real numbers as my domain of both of them because it only works for one of them. So that's why here we have to restrict it. And they told us what it's restricted to, so it's not that big of a deal. And then here's the words here. Up there it said determine. Here it says show that they are inverses. That means these are inverses. You have to show why. That means your work is your answer. It also tells you if you don't get X, you did something wrong somewhere. So those little words can be very helpful in knowing what your answer is supposed to be. So I'm going to start off with h of k of x, which is going to be h of the square root of x minus 10. So I'll take that, substitute it into h, and that will give me the square root of x minus 10 squared plus 10. So what is the square root of x minus 10 squared? X minus 10. So I get x minus 10 plus 10. That gives me x, which is what I was expecting, right? I knew that before I started. That's why it's not about the answer. The answer I know is going to be x. The work in between is what my actual answer to the question is. But then I have to also do k of h of x, which is going to be k of x squared plus 10, which is going to be the square root of x squared plus 10 minus 10. Now, anytime I substitute in something with more than one term, I put parentheses, because sometimes they matter, sometimes they don't. Right here, do these parentheses matter? No, they don't do anything except group things. It's not, nothing's happening there. So I could rewrite it without them, but I also don't need to do that. I just know I can ignore them, and so I have 10 minus 10, so that gives me the square root of x squared, which is x. Okay. We'll look more at domains for some of the other things that we do. What questions you got? Anything? All right. So then here again it says show that these are inverses. I know my answers are going to be x. I've got to show why. So I'm going to start off with n of p of x, which is going to be n of 6 over x plus 4. I'm going to take that, substitute it in everywhere I see an x here. So this is going to give me 6 over x plus 4 minus 4. Now, I know fractions in a fraction sometimes spike your anxiety. Don't just automatically think things are going to be difficult, and definitely don't start making up work, okay? So as I look at this, I put those parentheses in there. Do they matter? No. Okay, so can I zero out those 4's in the denominator? Yes. So that means that gives me 6 over x. And I can't say, oh, I'm just going to cancel out those x's, because if I just cancel them out, I don't go there, because you're not going to understand. Most of you are not going to understand how the fractions all work together just yet with that type of thing. But I have a fraction and a fraction. Fractions are not that scary. They just represent division, right? That's why the division sign is what it is, because hey, look, this is a fraction, right? So this represents division. We know how to divide fractions. I take the numerator, that's 6. And what this says is 6 divided by 6 over x. I change that to multiplication, keep, change, flip, and I take the reciprocal here. That's x over 6. Now what happens with the 6's? They cancel out, and I get x. If I cancel them out here, I'd be left with 1 over x. I still have an issue, but sometimes people start doing that and they're not canceling them out of the right spot, and Don't even worry about overthinking it. Just change it and everything will work out nicely. Okay, we okay with that? All right, so now you're going to do P of n of x. So that's going to be P of 6 over x minus 4. And I'm going to give you a minute for you to work on that on your own. Okay, so all I've done right here is substituted in. I'm pretty confident, because I know I'm supposed to get x, I'm pretty confident that those 4s are going to zero out. But can I legally do that at this step? No. Okay. That's right. Absolutely. So instead here, I'm going to do this keep, change, flip. So I got 6 times, and then I take the reciprocal. That's x minus 4 over 6 plus 4. And it's okay to do more than one thing in one step. You just don't really have a mathematical reason of why you can zero those out, right? So, but here, I can cancel those 6's out. Then I'm left with x minus 4 plus 4, which gives me x. And if you wrote an extra step in there, that's fine. But you didn't have to. It's okay. It's okay to skip some steps. It's not okay to skip all of them. All right, what questions you got? Anything? Awesome. Then grab your first pink piece of paper. You'll know it's the first one because it doesn't say continued at the top. It looks like this. This is going on page 75. Okay, so f and g are inverse functions, or if they are. Then g is equal to f inverse of x. And not only that, but f of x is equal to g inverse of x. Okay? And then we know that if we have xy as a point on the graph, then yx is the point on the graph of g of x. It's the graph on its inverse. We know how to do that. We did that yesterday. With inverses, all of the x and y values are switched. So the graphical behaviors in terms of x and y will also be switched. The domain of f is the range of f inverse. X and y get switched. Domain represents x, range represents y, so we also just switch those entire things. Okay, works the same way every time. A continuous, and here's another little tidbit here, a continuous function will only have an inverse function if it is strictly increasing or decreasing. Otherwise, it will not pass the horizontal line test, which we'll talk more about tomorrow. But let me explain to you what that means here. Let's look back at this graph again. So my parabola is decreasing, and then it starts to increase, right? You agree with that? So it's switched between increasing and decreasing. Well, when we took the inverse, now this does not pass, my inverse is not a function because this function was increasing or decreasing and then increasing. If I took a cubic function that looks like this, and I took its inverse, it's going to look something like this. And since this is strictly increasing, when you take the inverse, you also get a function. Okay, so that's what that number 4 or whatever bullet that was, that's what it's talking about. And we'll see it more as we go through some other things, but that's what it means by the original being strictly increasing or decreasing. Okay, back to here. So we'll talk, I know that's wordy stuff. That'll come up as we go through this here. All right, so let f be a continuous function with selected values in the table below, which is actually above. let G be the inverse of F. Okay, so notice we're asked about G in here, but what this is telling me is this right here. G of X equals F inverse of X. Okay, and we're going to find the following if possible. So F of 0. Well, this one doesn't really have anything to do with inverses. We've done this. F of, what is F of 0? 1. So I really want F of 1. And then what is F of 1? Negative 1. Everybody okay with where all that came from on the table? All right. So now I have G of negative 3. I highly encourage you to rewrite it as what it says right here. G of negative 3 is F inverse of negative 3. Well, if I take the F of X, I take the F inverse of the Y value. I'm looking at it backwards, right? So what is F inverse of negative 3? 4. Everybody okay with why it's 4? Since it's the inverse, we look at the Y and find the X. Okay. So G of 6 is going to be F inverse of 6. And what is that? Negative 3. Very good. Any questions about where those are coming from? Speak now, or you're going to be lost for the rest of the class. All right. G of negative 1. I would rewrite that as F inverse of F inverse of negative 1. So you figure that one out. Do you get 0? If not, ask me a question. Okay, I'll take that as we all understand. Now, I think, kind of taken in, not really official polls, but I think we can all, most of us anyway, kind of like this notation better than this notation. I always rewrite it so I don't accidentally do something weird, and y'all see me accidentally do weird stuff all the time, so I know that I'm capable of it, and I don't want to miss something that's fairly simple here. So that's F inverse of F of negative 2. So what is F of negative 2? 3. And then F inverse of 3 is negative 2. Very good. And then what is F inverse of negative 3? 4. Now notice B and F, these two are really this exact same question. One's just asked in terms of G and one is asked in terms of the inverse. But when we rewrote it, you can see it's literally the exact same thing. We good with that? I can tell you from calculus experience, College Board loves these tables and stuff with stuff like this. So if you're not understanding where the numbers are coming from, let me know. All right, now that's just with the table. Now what if we have a graph? With the graph, we have a couple of options. One option is to go ahead and graph the inverse. We're going to do that on this one to make sure we understand it, but then we're going to do the rest without graphing it because I want you to be able to do it without taking the time to graph it every time. The first thing we want to do is to graph in the line y equals x. Okay, I suggest you do it as a dotted line. I'm going to do mine as a bright green line. And the grid itself is not a square, so don't go from corner to corner. Find where would make sense for the line to be. It should be right there. And then when we did these yesterday, we made up a chart, and then we made up a new chart, and you can totally do that, but you don't have to. I know that this point here is at negative 4, negative 3, so the inverse will be at negative 3, negative 4. Okay. This point is at 4, negative 1, so the inverse will be at negative 1, 4. This one is at 6, 4, so the inverse is at 4, 6. Well, I can't get it right on the close enough. This point is at 11, 6, so the new point will be at 6, 11, which is way off my graph, so I'm not going to worry about it. Then I can connect the dots. Something like that. Now, notice that green line didn't really help us in graphing that, but it helped me second period, because I know you're going to be shocked about this, but I plotted one of my points wrong. I only went to 3 here instead of 4. But when I was done then, I looked at this and I was like, something doesn't look right. Like they didn't look like they were the same shape, or it didn't really look like a reflection over that line. So that helped me catch myself before I moved on and used wrong numbers. Okay? Or before somebody called me out, which is fine too. All right, everybody with me so far? We good? Okay. So now let's see what this is asking us here. It says, what is the minimum value of k of x? Well, this is the graph of k, so this is k of x. This is k prime of x. Not k prime, oh my gosh. K inverse of x. On my k graph, the minimum point is right here. The value is always the y value. The location is the x value, because the ordered pair here is 4, -3, right? -4, -3, sorry. And so it's at -4, but the minimum value is -3. Everybody okay with that? That's old business there. Then it asks me the minimum value of k inverse. Well, now I graphed it so I can figure that out. What is the minimum value? -4. Okay. But let's say that I didn't graph it, or I couldn't graph it, or whatever. Then remember that x and y switches. If I want the minimum y value, that's what my minimum value is. Since x and y change places with the inverse, the minimum value is the minimum x value of the original one. And that's what that is right there. Okay? That was my minimum x. Bless you. All right, so then what is k inverse of 6? 11, okay? K inverse of 6, so on my k inverse graph, if I go to 6, I'm supposed to be at 11, which is off the graph, and I can't get there, and I think my thing looks weird anyway. I didn't even graph it right, but it's okay. Then what is k inverse of 4? K inverse of 4, so on my inverse graph, when x is 4, y is 6. Another way to look at this is what this is saying is that k of x is equal to 4. So on my original function, I'm looking at what x value gives me a y value of 4. So if I did not have my pink one there, I would go to y at 4, figure out that this is my point here, so my x value is 6, and that's where it's coming from. Okay? What questions do you have? You understand how to use those there? All right. No questions at all? All right, flip it over. All right, so the function f is defined over the interval from -2 to 8, which I can see. Sometimes what they're telling you is stuff that they have given you. That doesn't mean don't read the question, okay? As shown above. And this is the graph of f. So I'm going to put a big F here so I know it's f and not f inverse. But then it says let f inverse represent the inverse of f. So that's nice. It's not an f and g thing. It is f and f inverse. But this is the graph of f. And we're not going to graph f inverse, right? We're going to think through how to figure these things out. The maximum value of f inverse is what it's asking me for. Before we get to that question, what is the maximum value of f? 7, because that is the maximum y value, right? I want the maximum y value of the inverse, so what do I look for on f? The maximum x value. And then my maximum x value is 8. So my answer here is 8. Does that make sense to you? Without having to graph everything. And think about if we did graph it, then this thing would reflect in y equals x, and this part would reflect up here, this would reflect down there, and that's definitely going to be your highest y value that you have. Okay? Worst case scenario, you have to graph them all, but the idea is to understand the concept so we can think through other things and not always have to regraph everything. All right, so f inverse of 3. What do you think that is? 2. Because remember, this is saying f of x equals 3. So when my y value is 3, what is the x value? And that is 2. So what is f inverse of 1? 3. Okay, f inverse of 1, remember this is your y value. So I go to y, f inverse of 1 will be 3. Everybody okay with that? All right. Then I'm asked for the domain of F inverse. So the domain of F inverse is equal to the range of what? Of F, okay? So from this graph, can you figure out the range of F? Where do we start? -3. We start here at -3, right? And we go until where? 7. Do I include both of these? Yes, I do. Domain and range, literally just switch places. Okay. What questions you got on that? We good? Okay. So now we're going to kind of mix the two kind of things together here. We have this graph. Let's read and see what it says here. It says that the function g is defined over the interval from -3 to 10. Okay, that's good. And it's shown here. G inverse is the inverse of g. Good. So this is the function g. I'm going to write it big so I don't mess these up. Values of the increasing function h are given. So since it's increasing the whole time, that means that the inverse will also be a function, and this is h. We're going to find the following if possible, because remember, some things may not be possible if they're not defined for me. All right, so I want g of h of 6. So that means I want g of, what is h of 6? 10. And then what is g of 10? -1. Okay. Everybody good with that? All right. So then I want g inverse of h of 0. What is h of 0? 3. And then g inverse of 3 is 4. Y'all agree with that? All right. If you haven't already zoomed ahead of me and finished, do C and D on your own. I'll put, and I'll write them out, but don't look at mine until you're done. Oh, I can't do that because then I can't see the graphs. So this is h inverse of g of 8 is 0. H inverse of 0. G inverse is 10. H inverse 10 is 6. All right. So when you're done, check those two. Let me know if you have any questions. Are we good? Okay. Then I think we're going to stop here today, which means we're not even going to touch that other pink piece of paper yet, because this is where I got my morning classes. I'll go ahead and give you the assignment. On the assignment, you already have all the knowledge you need to do it. The second pink paper, that's going to be on an assignment that I give you tomorrow. But this one, I just wasn't sure how I'd space all this out, so I had them all ready for you.